Yo, what's great, everybody? Today's a beautiful day. It's a day we never seen before and a day we'll never ever see again. Everywhere else in the world, I'm known as Eddie One Take, but on this channel, I'm known as RTX Eddie. Now, if you've been watching my channel, then you know I'm documenting my whole cybersecurity journey, my whole hacking journey, and if you haven't been here, then that's what we're doing. So you're invited to learn with me. What I'm going to be doing today is I'm going to be going through Linux fundamentals. Now, Linux is an operating system. An operating system like Windows or Mac. And I remember maybe 2 years ago when I had a friend named Paul. He was in cybersecurity. He was driving a Tesla and everything, and he had a really good job. So I'm like, yo, bro, what do you do? He was like, I'm in cybersecurity. So I was like, yo, I want to get into that, bro. What do I do? Like, where do I start? How do I learn? And he was like, yo, bro, okay, start to look into Linux. Start to look into Kali Linux and things like that. And it was so foreign to me at the time. I was just like, okay, cool. And when I seen the terminal, I was just so intimidated. But I want to give a shout out to my cousin Marquise and my cousin OJ as well. Marquise is the one who kind of like encouraged me to really focus on cybersecurity. He was on a project overseas and he had some like friends. They were young and they were making like crazy bread, like 16,000 was it 16,000 a month, a week, something like that. Something 16,000, right? But it was in a short period of time. I think like a week or 2 weeks. A month. I think it was 16,000 a month. Whatever, something like that, right? But he was talking about how they did cybersecurity, and you know he went ahead and got some certifications. So I was proud of him for that, and I was like, damn, this shit is for real. So I started looking into cybersecurity specifically, and he encouraged me because he was like, yo, bro, this is what you already know how to do. So when I learn this stuff, I kind of get it quick. It's kind of like when I watch like movies like Drumline or situations where somebody knows how to do something but they don't like know they know how to do something, or it isn't up to standards, right? It felt like that. So I say all of that to say we got to learn Linux if we want to get into cybersecurity, guys. So look, I'm going to be learning Linux, and I invite you to learn with me. All right, so Linux, as you might already know, is an operating system used for personal computers, servers, and even mobile devices. However, Linux stands as a fundamental pillar in cybersecurity. And this platform that I'm using is called HackTheBox. Shout out to my boy Civil. Shout out to Shell as well. They've been monumental in my learning experience, helping me with resources like this. But this is HackTheBox if you want to learn about cybersecurity. The reason why I recommend if you want to learn about cybersecurity, then I would recommend HackTheBox like Civil recommended me. The reason why I recommend it is because it's best for the way I learn. Some people are visual learners, some people are audio learners. I'm hands-on, and this is the best way to understand or get an understanding of cybersecurity is to do things hands-on. So what I'm doing here is just taking notes on the side. Renowned for its robust flexibility and open source nature. That's something I notice about it as well. Okay, in this section, we are going to cover the Linux structure, the history, philosophy, architecture, and file system hierarchy. Essential knowledge for any cybersecurity professional. So the Linux structure, the history, the philosophy, the architecture, and the file system hierarchy. That's what we're gonna be learning. You can think of this as your first driving lesson for a new car, getting a basic understanding of the vehicle, what it consists of, and why it is the way it currently is. So basically, if I'm learning Linux, I'm learning how to drive a car again. So I'm excited. I think the best way to learn how to drive a car is to actually drive. So to begin, let's define what Linux is. Linux is an operating system, just like Windows, Mac OS, Mac operating system, iOS, I guess iPhone operating system, and Android. An operating system is software that manages all the hardware resources of the computer, facilitating communication between software applications and hardware components. So, how I'm going to understand this is that an OS, Windows, Mac OS, iOS, Linux, Android, is software that manages all the hardware resources of a computer. When I put this computer together, you can watch videos earlier on this channel where I get all the parts and I put this computer together. I had to decide on a OS. I had to decide on an operating system that I wanted to use to manage all of the hardware resources on this computer that I put together. So the management of that consists of facilitating communication between software application and hardware components. So that makes sense. Like my graphics card, if you watch the video where I like almost lost it, I almost lost my mind when I thought I broke my motherboard. Let's just say my GPU, for example. There's software that communicates, that facilitates the communication between like my GPU and the software on my computer. Unlike some other operating systems, Linux comes in many different distributions. Okay, so I'm learning something. So unlike, I guess, Windows and Mac, Linux comes in many different distributions. What does that mean? I don't know what that means. Often called distros. So, okay, I think I'm starting to get it. Linux comes in many distros, which are basically versions. Okay, so Linux comes in many different versions. Linux tailored to various needs and performances. Okay, so hence why there's Linux, there's Kali Linux. Okay, I'm getting it. So I'm understanding the structure of Linux. All right, Linux comes in distros. Copy. Okay, let me get some notes real quick. Some valuable notes. We just learned that Linux is simply an operating system, just like Windows, Mac OS, iOS, Android OS, or Android, not Android OS. And that Linux comes in different versions called distros. So if I say I'm using Linux, there's a specific distro of Linux that I will be using. All right, so let's talk about the history of Linux. Many events led up to creating the first Linux kernel. Okay? Many events led up to creating the first Linux kernel. Like a popcorn kernel? And ultimately the Linux operating system, starting with the Unix operating system's release by Ken Thompson and Dennis Ritchie. That's a cool way to spell Ritchie, whom both worked at AT&T at the time in 1970. Okay, let's do some research now. So many things led up to the first Linux kernel and the first Linux operating system. So the first one of these many events was the Unix operating system. Let's check these guys out. Okay, let's check these guys out. So Unix we'll get to, but let's see who Ken Thompson is. Let's do some OSINT. Let's gather some intelligence. All right. This is Ken Thompson, American designer. Wikipedia, Kenneth Lane Thompson. Let's just see. Kenneth Lane Thompson, February 4th, 1943, an American pioneer of computer science. Thompson worked at Bell Labs for most of his career, where he designed and implemented the original Unix operating system. Okay, so this is the designer, Kenneth Lee Thompson. Shout out to you, Kenny. He also invented the B programming language, the direct predecessor of the C language. Wow, hence why they call it C language. And was one of the creators and early developers of the Plan 9 operating system. I've never heard of this operating system. Since 2006, Thompson has worked at Google, where he co-developed the Go language, a recipient of the Turing Award. He is considered one of the greatest computer programmers of all time. That's fire. Shout out to Ken Thompson. Ken Thompson. All right, so now we know who Ken Thompson is. Let's just see what Unix is from clicking this on Wikipedia. So this is trademarked. It's a family of multitasking, multi-user computer operating system that derive from the original AT&T Unix. Okay, so AT&T used Unix, whose development started in 1969 at the Bell Labs Research Center by Ken Thompson. Dennis Ritchie. All right, so we got to find out who Dennis Ritchie is too. And then just from my own notes, I got you. I know what I'm gonna do. Boom, boom. We'll just keep it here. Just keep it all in the box. Who is Ken Thompson, the original creator of Unix? Now, do your homework. Do your homework on Dennis Ritchie. Let's see what's going on. Let's see what's going on with my boy Dennis. We went Unix, and then we went. Okay, so a family of multitasking, multi-user computer operating systems. Okay, I think I get it. I need more context though. All right, Dennis Ritchie. Shout out to my boy. Rest in peace. Passed away in 2011. Dennis McAllister Ritchie. September 9, 1941 to October 12, 2011, was an American computer scientist. He created the C programming language and the Unix. Oh, that's funny. Ken created the B programming language. His boy Dennis created the C programming language and the Unix operating system. So they co-founded Unix together. And B language with longtime colleague. Okay, so they worked on a lot of these projects together, Ken and Dennis. Ritchie Thompson were awarded the Turing Award. Let's see what that is. I'm curious. Following curiosity right now. Prize given Association for Computing Machinery. Okay, that's fire. One day we're gonna get a Turing Award. That's cool. All right. So shout out to Dennis. Let's see. All right, so let me see something in here that I can pick up. Ritchie created C language. Nowadays, C languages operating system. Anything about Linux? I think the Linux phenomenon is quite delightful because it draws so strongly on the basics that Unix provided. Okay, Linux seems to be along the healthiest of the direct Unix derivatives, though there are also the various BSD systems as well as the more official offerings from the workstation. All right, so Unix came before Linux, and Unix is multitasking, multi-user. Multitasking, multi-user. So is that something that okay. Let me just continue to read. All right. So now I know who Ken and Dennis are. The Berkeley software distribution was released in 1977. But since it contained the Unix code owned by AT&T, a resulting lawsuit limited the development of BSD. When you start breaking down acronyms, I get curious, like, okay, cool. Let me see. And they explain what it is, but I want to know for myself. Okay, even the way that I'm like learning right now, shout out to HackTheBox. The way that I'm learning right now is because I went through the learning process, and it definitely changed the way that I learn and receive information right now. Changed the way that I ask questions, look at fear, a bunch of things. So I highly recommend it. But the Berkeley software distribution, when I think about Berkeley, I think about Berkeley, California, and the Bay. Shout out to the Bay. Software distribution, a group of Unix-like operating systems that originated, isn't that crazy, from the University of California, Berkeley. That is so interesting to me, right? That the Berkeley Software Distribution Group is a group of Unix-like operating systems, and it originated in Berkeley. These systems were developed by professors and students who extended the AT&T Research Unix operating systems. Key features include strongly enforced time-sharing system, making them suitable for environments where resources are shared. Shout out to the university. In California, Berkeley. University of California is in Berkeley. Okay, cool. Wikipedia this. People say Wikipedia is not a good source. I beg to differ. I used to feel the same way, but I beg to differ now. This is the Berkeley Software Distribution, BSD. Where was I? Here. All right, are we learning something? We learning something about Linux. I feel like it's important. People like to just rush into it. I feel like it's important. Like, you know, when you getting to learn a partner, you gotta. If I plan on using Linux, you gotta learn it. You gotta learn the history. You want to see the background, where it's from, how it started, so you can have that emotional connection with the information, and it sticks more. You know. Anyways, that's how I'm learning. So. 1977. That's interesting, and they had to come up with that because there was a lawsuit because the code was owned by AT&T. All right, got it. His goal. Okay, wait, got you. We got some names now, but since it contained the Unix code owned by AT&T, a resulting lawsuit limited the development of BSD. Richard Stallman started the GNU project in 1983. So, who is Richard Stallman? And what is the GNU project? Let's see who Richard Stallman is. Richard Stallman. And I'm going to spend time one day in the future going on YouTube to see if I can find any videos about these people. Just to learn more of the history and to see the way they thought and to see where, like, how far technology has really come and the developments that go along with it. Richard, where you at, Richard? Richard Stallman. Richard Matthew Stallman, born March 16th. Shout out to you, Rich. Your birthday passed last month, 1953. Also known by his initials, RMS. Richard Matthew Stallman is an American free software movement activist and programmer. He campaigns for software to be distributed in such a manner that its users have the freedom to use, study, distribute, and modify that software. Software which ensures that these freedoms is termed free software. Stallman launched the GNU project, founded the Free Software Foundation (FSF) in October 1985, developed the GNU compiler collection and GNU Emacs, wrote all versions of the GNU General Public License. Okay, so this guy is an activist. Shout out to you, Rich. Rich is an activist, someone who believes that software should be accessible to its users to use, study, develop, modify. I like that. Ensures that this term is called free software. Okay, what's the GNU project now? The GNU project is a free software mass collaboration project announced by Richard Stallman on September 27, 1983. Its goal is to give computer users freedom and control in their use of their computers and computing devices. All collaboratively developed and publishing software that gives everyone the rights to freely run the software, copy and distribute it, study it, modify it. GNU software grants these rights in its license. I like that. That's fire. Okay, so the GNU project was basically to give computer users freedom to control how they control their computers. All right, that makes sense. I like that. That's a fire project. But I'm curious, what does GNU stand for? What does GNU stand for? Do I see it anywhere here? That's gonna bother me. I gotta know what GNU stands for. GNU's. I don't. What is GNU though? It's a reactive acronym. It's a recursive acronym, as the G in GNU refers to the project itself. Okay, G. The project goes to develop a completely free Unix-like operating system known as GNU. What does the G in GNU stand for, bro? No way. Not Unix. G, not Unix. Okay, what? Let's go to Reddit, bro. GNU's not Unix. Okay, but what does the G stand for? Because GNU's the anim he liked. GNU's the whose name ends in NU? Well, you are not wrong. But the name also happens to be 3 letters and starts with a G. What? Is this an animal? The article. System CG. GNU project. Oh, look. This is a freaking animal. Okay, so let's put two and two together. Where is this GNU coming from? I know I'm getting a little bit off topic, but I'm really trying to understand. Like, I like to learn the history of these things. May have to come back to it. What does the G and GNU stand for? Holy, that's gonna bother me. All right, GNU's not Unix. I got that. That's over here. Oh, I saw a video where he explained why he wanted a recursive acronym because autism. And then what is a recursive acronym? He wanted it to be not Unix. Okay. Not Unix. Okay. And it's not Unix because it's not Unix. Unix was the code that was owned by Kenny and Dennis. Because so he just went through the alphabet looking for a word. A and U, not a word. B and U, not a word. C and U, not a word. D and U, not a word. E and U, not a word. F and U, not a word. G and U. Oh, look. A obscure African animal. I have a project name. Wow. Okay. I don't know how 100% true this is. He did say he's seen a video, but this is worth documenting. All right. That's interesting. That's interesting. GNU. We know what GNU not Unix is. Okay, cool. In 1983. Projects by others. Projects by others over the years failed to result in a working free kernel that could become widely adapted until the creation of the Linux kernel. At first, Linux was a personal project started in 1991. That's the year I was born. By a Finnish student named Linus Torvalds. Personal project. This was a personal project for Linus. And when I find these names again, I like to look up these people briefly and just get a better understanding. Always being a student. What up, Linus? Finland, Swedish. Born 28 December 1969 in is a Finnish software engineer who is the creator and lead developer of the Linux kernel. He also created the distributed version control system Git. The Linux kernel is a free and open source Unix-like kernel that is used in many computer systems worldwide. The kernel was created by Linus Torvalds in 1991 and was soon adapted as the kernel for the GNU operating system, OS. see something. GNU is an extensive collection of free software which can be used as an operating system or can be used in parts with other operating systems. All right. Okay, it's an operating system basically. Collection of free software linked with the GNU project, founded by Mr. Stallman. But we're talking about the Linux kernel. Unix, created to be a free replacement to Unix since the 19th. It's been included in many operating system distros, many which are called Linux. One such Linux kernel operating system is Android, which is used in most of the kernel code is written in C and supported by the GNU computer parlor collection. Also contain assembly code for architecture specific logic such as optimizing memory. Cool. All right, it's fire. Learning a lot. I'm learning a lot. His goal was to create a new free operating system kernel. Now, I don't know why they call it a kernel. Seriously, I don't know why, but kernel in computer science. Let's figure that out. In computer science, a kernel is kernel. A kernel is the core of an operating system, acting as the central point of control and interaction between. So the kernel is the point of interaction between hardware and software. Wow, this is a great picture to. I'm going to save this. Save this picture. Okay, that's interesting. Seeing how this stuff works. Cool. Over the years, the Linux kernel has gone from a small number of files written in C under licensing that prohibited commercial distribution of the latest version, with over 23 million source code lines. Sheesh. Comments excluded. Licensed under the GNU General Public License Volume 2, V2. Linux is available in over 600 distributions, or an operating system based on the Linux kernel and supporting software and libraries. Some of the most popular and well-known being Ubuntu, Debian, Fedora, OpenSUSE Elementary, Monero, Gentoo Linux, Red Hat, and Linux Mint. I know this one. I've seen this one. The rest of them, not really. Ubuntu and Debian. They're saying these are the most popular. All of these, though. So these are different distros of Linux that we will become familiar with if we need to. But at least we've made contact so we can have some type of familiarity to reference. Linux is generally considered more secure than other operating systems. And while it has had many kernel vulnerabilities in the past, it is becoming less and less frequent. It is less susceptible to malware than Windows operating systems and is very frequently updated. Linux is also very stable and generally affords very high performance to end user. However, it can be more difficult for beginners and does not have as many hardware drivers as Windows. Since Linux is free and open source, the source code can be modified and distributed commercially or non-commercially by anyone. Linux-based operating systems run on servers, mainframes, desktops, embedded systems such as routers, televisions, video game consoles, and more. The overall Android operating system that runs on smartphones and tablets is based on the Linux kernel, and because of this, Linux is the most widely installed operating system. Isn't it crazy that Linux is the most widely installed operating system, and the average person only knows about Windows and Mac, right? They're not even thinking about using Linux at all, but it's technically in almost all of the technology that we use. Okay, Linux is an operating system, just like Windows, just like iOS, just like Android and Mac OS. An operating system is software that manages all of the hardware resources associated with our computer, as we mentioned earlier. That means an OS manages the whole communication between software and hardware. Also, there exist many different distros, like it's like a version of Windows operating system. So you got Windows 9, 10, 11. Those are all operating systems. Those are all management systems for your communication between your software and your hardware. Okay. Copy. With the interactive instances, we get access to PwnBox, a customized version of Parrot OS. This will be the primary OS we will work with through the modules. Parrot OS is a Debian-based Linux distribution that focuses on security, privacy, and development. All right, so Parrot OS, PwnBox, Parrot OS. I've never heard of PwnBox, but I've heard of Parrot OS before. I was actually using it earlier in another module, so that was my first time being introduced to it. So let's learn more about it. This will be the primary OS. Parrot OS is a Debian-based Linux distro that focuses on security, privacy, and development. So Parrot OS is focused on these. It's a Debian-based Linux distro. Imagine Linux as a thriving company where its components are the dedicated employees, each with specific roles and responsibilities to keep operations running smoothly. The architecture serves as the organizational structure, outlining how these employees are arranged into departments and how they communicate to achieve efficiency and productivity. The philosophy represents the company's cultures and core values, guiding how these employees work individually and collaboratively, promoting principles like simplicity, transparency, and cooperation to reach common goals. This is a good analogy of what Linux is, in my personal opinion. Somebody who loves business, that's a great analogy. Philosophy here, the company's cultures and core values. Okay, cool. The Linux philosophy center on simplicity, modularity, and openness. The Linux philosophy centers on simplicity, modularity, and openness. This is the Linux philosophy. Let me note it. If I close it and save it, oh nah, it'll still, I'll still have to scroll. Okay. It advocates for building small, simple purpose programs that perform one task well. These programs can be combined in various ways to accomplish complex operations, promoting efficiency and flexibility. Linux follows 5 core principles. What are these 5 core principles that Linux follows? Let's figure this out. So everything is a file. Okay, that's pretty simple. Everything is a file. Everything is a file. That's the principle. Okay. All configuration files for the various services running on the Linux operating system are stored in one or more text files. All configuration files for the various services running on the Linux operating system are stored in one or more text files. So everything is a file. Okay, got it. Small, simple purpose programs. Linux offers many different tools that we will work with, which can be combined to work together. Small, single purpose programs. Ability to chain programs together to perform complex tasks. The integration and combination of different tools enable us to carry out many large and complex tasks, such as processing or filtering specific data results. Okay, the ability to chain programs together. Okay. Avoid captive user interfaces. I remember this when I did a little bit of research about Linux before. Linux is designed to work mainly with the shell or terminal, which gives the user greater control over the operating system. So this is where an operating system does not have a user interface. No user interface. Graphic user interface. No, they call it like a GUI, a graphic user interface, which is something we see with like Windows and Mac. Those all have graphic user interfaces. Linux does not have a GUI. Linux would be considered a shell, or it would be considered a terminal. Okay? All right. You got it? I got it. Cool. So it avoids captive user interfaces. Cool. Configuration data stored in a text file. An example of such a file is the /etc/password file, which stores all users registered on the system. Okay. That's simple enough. All right, components. All right, component. We have a bootloader. Description. A piece of code that runs to guide the booting process to start the operating system. Parent Linux uses the grub bootloader. OS kernel. The kernel is the main component of the operating system. It manages the resources from system's I/O device at the hardware level. Oh, it manages the resources from the system's on-off devices at the hardware level. I'm guessing. I guess so. Daemons. Background services are called daemons in Linux. All right, cool. Their purpose is to ensure that key functions such as scheduling, printing, and multimedia are working correctly. These small programs load after we booted or log into the computer. OS shell, operating system shell. The operating system shell, or the command language interpreter, also known as the command line, is the interface between the OS and the user. So you're going to be using an operating system shell. That's the communication point between the user and the operating system. The interface allows the user to tell the OS what to do. So the OS shell, or the operating system shell, is where we can actually tell the computer what we want the computer to do. That line of that command line that's like flashing and beeping and asking us to type in a command, or not asking us, but it's there for us to type in a command to tell the computer what we want the computer to do. That's the OS shell. The most commonly used shells are Bash, TCSH, Cash, Cash, Zash, and Fish. Yo, that's so crazy that they have these type of names for OS shells or this many type of OS shells. But that's good to note. Actually, this whole thing right here is good to note. OS shell. Okay. Graphic server. This provides a graphical subsystem server called X or X server that allows graphical programs to run locally or remotely on the X windowing system. Graphics server. Okay, it's a server. X server, graphics server. Okay, window manager, also known as a graphical user interface. Haha, this is what we were talking about, a GUI. There are many options, including Genome, KDE, Mate, Unity, and Cinnamon. A desktop environment usually has several applications, including file and web browsers. These allow the user to access and manage the essentials and frequently access features and services of an operating system. Window manager. Okay. Utilities. Application or utilities are programs that perform particular functions for the user and other program. All right. So, give me 1 second. All right. So we are understanding the philosophy and the components of Linux. I'm enjoying myself. I am enjoying myself. Okay. Now let's learn about the architecture. Okay. So the Linux operating system can be broken down into layers. So start looking at Linux in layers. Okay, hardware. Peripheral devices such as the system's RAM, hardware device. What are you reading, bro? It says hard drive. Yo, okay, so sometimes I think I'm dyslexic, but we still push through. CPU and others. Kernel. The core of the Linux operating system, whose function is to virtualize and control common computer hardware resources like CPU, allocated memory, accessed data, and others. The kernel gives each process its own virtual resources and mitigates conflicts between different processes. Kernel, the core of the Linux operating system. What is the function? The function is to virtualize and control common computer hardware and software resources. So it's controlling like the hard drive, the CPU. Okay, copy. So a shell, okay. A command line interface, CLI. CLI is command line interface. Also known as a shell that a user can enter commands into to execute the kernel's functions. So a shell is basically a command line interface. CLI, that's what we're going to use to basically make the computer do what we want it to do, command the computer. Execute the kernel's functions, as they would say. System utility makes available to the users all of the operating system's functionalities. So file system hierarchy. The Linux operating system is structured in a tree-like hierarchy and is documented in the file system hierarchy. Okay. Let's put this to the side. This picture as well. I think that's a good representation. Linux file system. Bin, boot, dev, etc, library, media, mnt, opt, home, var, user, tmp, system, proc, root, run. Ooh. Path description. The top level directory. Okay. Slash. The top level directory is the root file system and contains all of the files required to boot the operating system before other file systems are mounted, as well as the files required to boot the other file systems. After boot, all of the other file systems are mounted in standard mount points as subdirectories of the root. Okay, file system. So this slash XYZ, all of these others. So slash is the top level directory. Top level directory is the root file system. Okay. Not this one, but the main one. The root file system contains all of the files required to boot the OS before other file systems are mounted, as well as the files required to boot the other file systems. After boot, all of the other file systems are mounted at standard mount points as subdirectories of the root. So this is the main or the root file system, and it's required before anything else can start, and everything else is mounted as subdirectories of that root. Slash bin contains essential command binaries. Consists of the static bootloader, kernel executable, and files required to boot the Linux OS. Bin boot contains device files to facilitate access to every hardware device attached to the system. Dev to every hardware device attached to the system, etc. Local system configuration files. Configuration files for installed applications may be saved here as well. Home. Each user on the system has a subdirectory here for storage. Home. Shared library files that are required for system boot. Slash media. External removable media devices such as USB drives are mounted here. Slash media. Slash mount. Temporary mount points for regular file systems. OPT. Optional files such as third-party tools can be saved here. Root, the home directory for the root user root. This directory contains executables used for system administration, binary file systems, SBIN, TMP, /TMP. The operating system and many programs use this directory to store temporary files. This directory is generally cleared upon system boot and may be deleted at other times without warning. /user contains executable libraries, man files, etc. VAR. This directory contains variable data such as log files, email inboxes, web application related files, cron files, and more. All right, cool. So we learned what the Linux structure was. That was cool. Understanding the history of it, how it all started, the philosophy of it. Everything is a file. Small, single purpose programs. You can chain these programs together. That it has this ability, and it avoids captive user interfaces and configuration data stored as text files. All right, cool. So let's move on to the next section in this module, which is Linux distros. All right, so now I'm learning about Linux distributions. Linux distributions or distros, we learned in the last section, is different versions of Linux. Are operating systems based on the Linux kernel. They are used for various purposes, for servers and embedded devices to desktop computers and mobile phones. Linux distributions are like different branches or franchise of the same company, each tailored to serve specific market or customer preferences. While they all share the same dedicated employees or components, organizational structure or architecture, and corporate culture, philosophy, it's a great way to put it. Let's note take. Notate that whole thing. Offer its own unique products and services, software packages, and configurations, customizing the experience to meet diverse needs, all while operating under the unified brand and values of Linux. Each Linux distro is different with its own set of features, packages, and tools. Some popular examples include Ubuntu, discover the latest and greatest features in our most recent long-term supported release. So this is Ubuntu. Federal, Fedora, an innovative platform for hardware, clouds, and containers, built with love by you. It's 100% free and open source. Latest release 42. Leading Linux desktop, next generation. Okay. So these are all distros. CentOS is another distro. Special interest groups. Community-driven free software effort focused on delivering a robust open source ecosystem around the Linux platform. So all of these are on the Linux kernel, but they're just different distros tailored for different needs, for different customers, different preferences, different clients, things like that. Debian. Or is it Debian? It's completely free operating system. People, our philosophy, get involved and contribute. And when you see free, it's usually either nonprofit or you'll see contribute here for CentOS. Is this? No, this is Debian. Contribute. I don't see it here. Contribute here. Contribute there. I don't see it here. Support, maybe? Support somewhere there. Okay. And then Red Hat Enterprise Linux. Red Hat. Everywhere enterprise IT is headed, Red Hat Enterprise Linux is there. From the public cloud to the edge, it evolves to bring flexibility and reliability to new frontiers. So this beta for download offering beta programs. Okay. Leading enterprise. So for enterprises, they most likely use Red Hat. Okay. So those are all distros of Linux. Many users choose Linux for their desktop computers because it is free, open source, and highly customizable. Ubuntu, Fedora, Ubuntu and Fedora are two popular choices for desktop Linux and beginners. It is also widely used as a server operating system because it is secure, stable, and reliable, and comes with frequent and regular updates. Finally, we as cybersecurity specialists often prefer Linux because it is open source, meaning its source code is available for scrutiny and customization. I like how they worded that. Because of such customization, we can optimize and customize our Linux distro the way we want and configure it for specific use cases only if necessary. We can use those distros everywhere, including web servers, mobile devices, embedded systems, cloud computing, and desktop computing. For cybersecurity specialists, some of the most popular Linux distros are, but not limited to. Oh, okay. So for cybersecurity, we got these distros. ParrotSec, we mentioned Parrot earlier. Framework for, tools, Tools for every operation. Choose between 600 plus tools for every kind of red and blue team operation. Okay. Operating systems. I'm liking this. I'm liking what I'm seeing. I'm liking what I'm learning. Raspberry Pi. Ha ha ha. Needs an operating system to work. That is it. Raspberry Pi OS. Previously called Raspbian in our official supported operating system. Is our official supported operating system. Okay. All right. And then Black Arch. Black Arch Linux penetration testing distribution. I like Black Arch. I like the look of it. Cool. Black Arch over 2,800 tools. Black Arch Linux is an Arch Linux based penetration testing distribution for penetration testers and security researchers. The repository contains 2,845 tools. You can install tools individually or in groups. Black Arch Linux is compatible with existing Arch installs. For more information, installation instructions, report bugs. Full iOS contains multiple Windows managers. Slim iOS feature environment. Below you'll find screenshots. Okay. Ooh, Black Arch menu. Terminals, browsers, network, Black Arch, Bluetooth, Blueport, Black Arch, NeoFetch. All of this is new to me. I've never seen any of this before. It's a little bit less intimidating because I've been on this every single day. So some of this stuff is kind of looking familiar in terms of like how I'm reading it, how I'm sectioning off. Like I'm reading what's like usage, options, miscellaneous, example, notes. But I do not know how to use any of this yet, so I'm excited to learn. I don't know what any of these programs are. Black Arch Slim ISO. I like this though. Okay. The main differences between the various Linux distros are the included packages, the user interface, and the tools available. Kali Linux, as we mentioned earlier, shout out to my boy Paul. He was the first person to put me on Kali Linux. Is the most popular distribution for cybersecurity specialists. Oh, that's why he said learn it. He was trying to put me on game. Okay. Including a wide range of security-focused tools and packages. Ubuntu is widespread for desktop users, while Debian is popular for servers and embedded systems. Finally, Red Hat Enterprise Linux and CentOS are popular for enterprise-level computing. All right. It's making sense. Are they breaking down the... Well, let me just read it. Debian is a widely used and well-respected Linux distro known for its stability and reliability. It is used for various purposes, including desktop computing, servers, and embedded systems. It is an advantage package tool. Okay, so shout out to my boy Shell. Shout out to my boy Civil. They put me on to get my certified Red Hat penetration tester or Red Hat analysis certificate. And the guy was mentioning APT, and he didn't say what APT was. And like I said, when I see acronyms, I go crazy. I need to know what they are. But Advantage Package Tool. What is that? What is Advantage Package Tool? What is the purpose of it? Package management system to handle software updates and security patches. The package management system helps keep the system up to date and secure by automatically downloading and installing security updates as soon as they are available. This can be executed manually or set up automatically. Debian can have a steeper learning curve than other distributions, but it is widely regarded as one of the most flexible and customizable Linux distros. The configuration and setup can be complex, but it also provides excellent control over the system, which can be good for advanced users. The more control we have over a Linux system, the more complex it feels to become. The more control we have over a Linux system, the more complex it feels to become. I don't think I can comprehend that. However, it just feels that way compared to the options and possibilities we get. Without learning it with the required depth, we might spend way more time configuring easy tasks and processes than when we would learn to use a few commands and tools more in depth. We will see it in the filter contents and find files directory section. Filter contents, find file directory section. Okay, I see that there. Cool. Stability and reliability. Let me write that down for Debian. And what is Debian? Debian is a distro of Linux. The distribution is known for its long-term support releases, which can provide updates and security patches for up to 5 years. This can be especially important for servers and other systems that must be up and running 24/7. It had some vulnerabilities, but the development community has quickly released patches and security updates. In addition, Debian has a strong commitment to security and privacy, and the distribution has a well-established security track record. Debian is a versatile and reliable Linux distribution that is widely used for a range of purposes. Its stability, reliability, and commitment to security makes it an attractive choice for various use cases, including cybersecurity. Okay, so Debian is a good one that we're going to focus on. Debian and Ubuntu, but I like Black Arch too, and Linux. All right, cool. So that's Linux distributions. That made sense to me. I hope it made sense to you. If not, you gotta read it again. All right, let's go on to the next section. All right, not too bad. Quick, we moving through. Cool. This is one definitely. Gotta favorite this one. Okay. It is crucial to learn how to use the Linux shell. And what is the Linux shell? It is basically the terminal, or where we command the operating system. As there are many servers based on Linux. These are often used because Linux is less error prone as opposed to Windows servers. For example, web servers are often based on Linux. Knowing how to use the operating system to control it effectively requires understanding and mastering Linux's essential part, the shell. When we first switched from Windows to Linux, does it look something like this? Yes. User at who the user is, dash, tilde sign, star, money sign. Okay, Google. But yes, this is the terminal. Windows, going from Windows to Linux does look like this. A Linux terminal, also called a shell or command line. We got some notes, guys. We got some notes. Okay. Provides a text-based input-output. Oh, input-output. So we found out we were wrong earlier. That's a good thing. Now we know what this is when we see it. Provides a text-based input-output. Shell is the command line that provides text-based input-output. That's why it's so difficult to understand it at first, because it looks like just a bunch of lines of codes, but they're commands, and we're used to interfaces like this, right? Seeing all this, that's what we're used to, but Linux is text-based. Between users and the kernel for a computer system. The term console is also typical, but does not refer to a window, but a screen in text mode. The term console is also typical, but does not refer to a window, but a screen in the text mode. In In the terminal window, commands can be executed to control the system. So that's what we're doing here, executing commands to control the system. That's where you execute your commands to control the system. Terminal emulators. What are terminal emulators? Terminal emulation is software that emulates the function of a terminal. Is software that emulates the function of a terminal. It allows the use of text-based programs within a graphical user interface. Text-based programs inside of a GUI. These are also so-called command line interfaces, CLI, that run as additional terminals in one terminal. In short, a terminal serves as an interface to the shell interpreter. I think I get it. Kind of get it. Picturing it in my head. Okay, I love these. Imagine you're in a large office building where the shell is the main server room that processes all the company's data and commands. Got it? The terminal is like a receptionist desk that serves as a point of communication to the server room. Okay, got it. You go to the receptionist, you go to the terminal to deliver instructions or requests to the server room, the shell. Got it. This is the technical. It's like the left side of the brain, right side of the brain. Yes, it makes sense. It comes together. Now, suppose you're working remotely. All right, say I'm at the crib, right? Terminal emulation softwares act like a virtual receptionist that's on your computer screen, the GUI. Terminal emulation software acts like a virtual receptionist that's got you. Allowing you to interact with the server room without being physically present in the office. It emulates the function of the actual receptionist desk, enabling you to use text-based programs and commands within a graphical environment. Copy. Function of copy. Additionally, CLI, command line interfaces that run as additional terminals within one terminal are like having multiple virtual receptionist desks open on your screen simultaneously. Okay, got you, CLI, okay. Each one allows you to send different instructions to the server room independently, but through the same main interface. In essence, the terminal server as your gateway to communicate with and control the core operations managed by this shell. Terminal emulators and multiplexers are beneficial extensions for the terminal. They provide us with different methods and functions to work with the terminal, such as splitting the terminal into one window, working in multiple directories, creating different workspaces, and much more. An example of the use of such a multiplexer called TMUX could look something like this. Terminal, Bloodhound example DB, Bloodhound Linux, Cryolite, terminal, TMUX, Bash. I remember them speaking about Bash. Copy. All right. Shell. That was emulators. The most commonly used shell in Linux is the Born Again shell. Oh, Bash, Born Again shell. Everything's like an acronym in computer science. Better believe they got an acronym for everything. And is part of the GNU project. Everything we do through the GUI or the GUI, we can do with this shell. The shell gives us many more possibilities to interact with programs and processes to get information faster. Besides, many processes can be easily automated with smaller or larger scripts that make manual work much easier. These are other shells. Okay. Copy. Copy, copy. All right, so that's the introduction to shells. A little bit confusing, but I know I'll get it as I go along. Got a couple more before we start actually getting into some things. All right, cool. All right. Let's do this. Okay. Prompt description. The bash prompt is simple to understand. By default, it shows information like your username, who you are, your computer's name, basically the host name, and the folder directory you're currently working in. It's a line of text that appears on the screen to let you know the system is ready for you. Okay, got you. The prompt appears on a new line, and the cursor, the blinking line or box, is placed right after it, waiting for you to type a command. It can be customized to provide useful information to the user. The format can look something like this: username, who you are, the computer name, host name, currently working directory, so the directory that you're in. The home directory for a user is marked with the tilde and is the default folder when we log in. Okay. The $ in this case stands for a user. Username, host name, home directory. As soon as we log in as root, the character changes to a hash and looks like this. Okay. 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 Okay, so this is just telling you basic information about the computer, and then when you log in as the root directory, then it's gonna look like this. And that's prompt description. Okay. For example, when we upload and run a shell on the target system, we may not see the username, host name, and current working directory. This may be due to the PS1 variable in the environment not being set correctly. In this case, we would see the following prompts: PS1 variable in the environment not being set correctly. Unprivileged user shell prompt, just a $. Oh, got you. That's basically what we said. When you're not logged in, $. When you're logged in, £. All we do is numbers. Money sign, unprivileged, privileged, copy. The PS1 variable in Linux systems controls how your command prompts look in the terminal. It's like a template that defines the text you see each time the system is ready for you to type a command. By customizing the PS1 variable, you can change the prompt to display information such as your username, your computer's name, the current folder you're working in, or even add colors and special characters. I like that. So the PS1 variable. This allows you to personalize the command line interface to make it more informative and visually appealing. In addition to displaying basic information like your username and current folder, you can customize the command prompt to show other useful details such as the IP address, date, time, and the success or failure of the last command. This customization is especially helpful during penetration tests because it allows you to keep track of your actions more effectively. That makes sense. For instance, you can set the prompt to show the full path of the working directory instead of just its name, and even include the target's IP address if needed. Using tools like script or reviewing the .bash history file located in the user's home directory, you can record all the commands you've used and organize them by date and time, which aids in the documentation and analysis. That's smart. The prompt can be customized using special characters and variables in the shell's configuration file .bash rc for the bash shell. For example, we can use the /u character to represent the current username, /h for host name, and /w for the current working directory. Special characters, date and time, or the date, like that. Okay, date like that. Full host name, number of jobs managed by the shell, new line, carriage return, name of the shell, /s/t, current time, /t, current time, /u, username, full path. Okay. Customizing the prompt can be a useful way to make your terminal experience more personalized and efficient. It can also be a helpful tool for troubleshooting and problem solving, as it can provide important information about the system's state at any given time. In addition to customizing the prompt, we can customize their terminal environments with different color schemes, fonts, and other settings to make their work environment more visually appealing and easier to use. However, we see the same as when working on the Windows GUI here. We are logged in as a user on a computer with a specific name, facts, and we know which directory we are in when we navigate through our system, facts. Bash prompt can also be customized and changed to our needs. The adjustment of the bash prompts is outside the scope of this module. Copy. However, we can look at bash prompt generator. You have not added any elements to your prompt yet. Okay. And power line. GitHub power line. Add font entry for Ubuntu. Okay. All right, cool. I like that. Prompt description. Moving right along. Getting help. Having established a solid foundation in Linux structure, its various distros, and the purpose of the shell. I gotta CLI, command line interface. The shell basically is the interface between the user and the kernel. Okay, got you. We're now prepared to put this knowledge into action. It's time to dive in, using commands directly in the terminal, as well as learning how to seek help when we encounter unfamiliar ones. We will always stumble across tools whose optional parameters we do not know from memory, or tools we have never seen before. Therefore, it is vital to know how we can help ourselves to get familiar with these tools. The first two ways are the man pages and help functions. So basically, this is my navigation for when I get lost. Man pages and help functions. It is always a good idea to familiarize ourselves with the tool we want to try first. We will also learn some possible tricks with some of the tools that we thought were not possible. In the man pages, we will find the detailed manuals with detailed explanations. I'm guessing man pages is short for manual pages. First command, getting help. The username, RTX Eddie. HTB. HackTheBot. And the directory that I'm working in, and unprivileged access. I like that. I like that now I know what this means. Because I was looking at it like, dude, what the it's funny. It's funny actually learning. Okay, the process of learning is if you're not having fun during the process of learning, then I'm not sure you're really learning. But that's a whole nother. Let's get into it. Save that. I need the backup one for prompt description. For example, there was something here I wanted to copy. Home directory. I wanted to copy this stuff. $. Prompt description. All right. And then special characters, that's for prompt description. All right, cool. Now I'm back to getting help. Copy. Okay, learn what this is. LS. I remember this from a little bit of the Linux that I was trying to learn. Forgot what it stands for. We are about to learn, though. We are about to learn. The ls command in Linux and Unix systems is used to list the files and directories within the current folder or any specified directory. allowing you to see what's inside and manage files more effectively. Like most Linux commands, ls comes with additional options and features that help you filter or format the output to display exactly what you want. To discover which options a tool or command offers, there are several ways to get help. One such method is using the man command, which displays the manual pages for commands and provides detailed information about their usage. So, okay, got it. Syntax. Username, hostname, directory, privileged, man, and then tool, syntax, bracket, tool. Let us have a look at an example and get help from the ls command. We type ls, ls1, user commands ls1. Oh, man ls. Okay, so manual and then ls or whatever command, but man ls. Name ls list directory contents. Synopsis ls option file description. List information about the files, the current directory by default. Sort entries alphabetically if none of CFT UV SUX nor -- sort is specified. Mandatory arguments to long options are mandatory for short options too. -A or -A -- all. Do not ignore entries starting with dot. Capital or capital A almost -all. Do not list implied and author. Manual pages ls. Okay. After looking at some examples, we can also quickly look at the optional parameters within browsing through the complete documentation. We have several ways to do that. So the syntax is tool -- help. Okay, syntax example. And then parameters. Yikes. What are you doing? Okay. Usage ls option file. List information about the file's current directory by default. Sort mandatory arguments. Too long options are mandatory for short options too. Do not ignore. Do not without print author each file. Print C style. Some tools or commands like curl provide a short version of help by using -h instead of --help. Curl. Okay. That makes sense. Makes a lot of sense. I don't know why I keep starting the space off. Did it do that before? No. I don't know why it keeps doing that. Where was I? Curl. Syntax. Curl H. Usage curl options, abstract Unix, socket, path, connect via abstract Unix domain socket, pick any authentication method, append to target file while uploading, use HTTP basic authentication, CA cert, CA path cert. As we can see, the result from each other do not differ in this example. Another tool that can be used in the beginning is apropos. Each manual page has a short description available within it. This tool searches the descriptions for instances of given keywords. Okay, so let's take our notes with that too. Sudo. Okay, sudo 8. Execute a command as another user. Sudo config 5. Sudo frontend. Sudo plugin API. How to run administrative commands. Execute a command as another user. Default sudo security policy plugin. Replay sudo session logs. Edit the sudoers file. Another useful resource to get help if we have issues to understand a long command is explain shell. Write down a command line to see the help text that matches each argument. Next, we'll be covering a large number of commands, many of which may be new to you. However, you now know how to seek help with any command you're unfamiliar with or unsure about. its options. Also, we highly encourage you to explore your curiosity. Take as much time as needed to tinker and experiment with tools presented. It will always be time well spent. Copy, getting help. Now, let's get into it. All right, this means I have to connect to something and do something and answer questions. So cool. Let's do it. System information. Now, let's dive into some hands on practice to get comfortable with using the terminal and the shell. Keep in mind that you can always use the -h or --help or man commands to access help if needed. Since we'll be working with various Linux systems, it's important to understand their structure, including system details, processes, network configurations, user/user settings, and directories, along with their related parameters. Below is a list of essential tools to help gather this information. Most of these tools come pre-installed. However, this knowledge is not only crucial for routine Linux tasks, but also plays a key role when assessing security configurations, identifying vulnerabilities, or preventing potential security risks in Linux operating systems. Okay, command. Okay, we got some work here. Who am I? Displays current username. ID returns user identity. Hostname sets or prints the name of current host system. Uname prints basic information about the operating system name and system hardware. PWD returns working directory name. Ifconfig. The ifconfig utility is used to assign or to view an address to a network interface or configure network interface parameters. Ifconfig. IP is a utility to show or manipulate routing network devices, interfaces, and tunnels. Netstat shows network status. SS, another utility to investigate sockets. PS shows process status. Who displays who is logged in. ENV prints environment or sets and executes commands. List block devices. LS block. LS USB devices. LS open files. LS PCI devices. Let us scroll down to the bottom of the page, spawn the target machine, then connect to it using SSH. Then try to follow along and reproduce as many of the examples shown in this section. Logging in via SSH. First, my instructions were to go down to my machine. I already have that. Low load recommended protocol UDP. UDP, I forgot, but I know transmission control protocol. Let's start our instance. I'm gonna learn the fundamentals of Linux within this 6 hours. Okay, so we have our terminal up and running. Let's go back up. Okay, system information. Secure Shell SSH refers to a protocol that allows clients to access and execute commands or actions on remote computers. So SSH is for remote access and command execution on Linux-based servers and hosts, as well as other Unix-like operation systems. SSH is one of the permanently installed standard tools and is the preferred choice for many administrators to configure and maintain a computer through remote access. It is an older and very proven protocol that does not require or offer a graphical user interface or a GUI. For this reason, it works very efficiently and occupies very few resources. We use this type of connection in the following sections and in most of the other module lab exercises to offer the possibility to try out the learn commands and actions in a safe environment. We can connect to our targets with the following command: SSH HTTP student at IP address. Okay. Okay. Now let's look at a few examples on the machine we have just logged in. Host name. The host name command is pretty self-explanatory and will just print the name of the computer that we are logged into. Okay, so this is my terminal and the way we are going to open up. Let's open this terminal up, the bash. Okay. Let's try one of our commands. Who am I? This is who I am. HackTheBox, AC. Okay, cool. So if I did this and I did, oh, that's a command. I just tried to copy it. Okay. If I did, SSH, HTTP student, IP address. All right, cool. Let me just pay attention, follow along. Host name. This is the host name. WMAVOGZINQ. Okay, that's the name of the computer that we're logged into. Who am I? That's what we just did. This quick and easy command can be used for both Windows and Linux systems to get our current username. During a security assessment, we obtain reverse shell access on a host. And one of the first bits of situational awareness we should do is figure out what user we are running as. From then, we can figure out if the user has any special privileges or access. Who am I? We just did that. We'll do it again. This is who I am. This is the host name. Okay. ID. The ID command expands on the who am I. So who am I and ID are connected. Prints out our effective group membership and IDs. This can be of interest to penetration testers looking to see what access a user may have, and sysadmins looking to audit account permissions and group membership. In this output, the HackTheBox group is of interest because it is non-standard. The ADM group means that the user can read log files in /var/log /var/log and could potentially gain access to sensitive information. Memberships in the pseudo group is a particular interest, as this means our users can run some or all commands as the all-powerful root user. Okay, what does that mean? It means ID can show me who has permissions, and depending on what permissions certain people have, they can do certain things. Pseudo rights could help us escalate privileges or membership in the pseudo group. Escalate privileges or could be assigned to a sysadmin that they may need to audit permissions and group memberships to remove any access that is not required for given users to carry out their day-to-day tasks. System information, ID. Let's do that. UID 1002, HackTheBot AC, GID 102. So user, I guess, G, I'm not sure. HackTheBot groups 102, 27 pseudo, 100 users. Okay, cool. Okay. Uname, UID, like they say here. Okay. Audit account permissions. Pseudo group. How many users should them? Oh. Group, HackTheBox, ADM. The ADM group means that the user can read log files. Okay, this group means that the user can read log files and can potentially gain access to sensor. In the pseudo, okay, members in the pseudo group can run some or all commands as the, oh wow, 27 people. Copy, making sense now, Okay, making sense. Okay, got it. We did ID. Let's dig into the uname command a bit more. If we type man uname in our terminal, we will bring up the man page for the command, which will show the possible options we can run with the command as the results. System information. So we're typing man uname. Whoa, it happened. It worked. And I think it, oh no. Oh, okay. So this is, no, I'm lying. Oh, I don't know what happened to all that stuff I was just typing. Okay, anyways. Print system information, synopsis. Print system information with no option, same as all. Corutils 9.1. Okay. License. Okay. Copy. All right. Got it. There's no going back. I don't know how to go back with this. Line 146, 40. For help or Q to quit. Okay. Q. Oh, wow. Copy. Got it. Menu name. Okay. Which will show the possible options we can run with the command and the results. No name, kernel release, hardware platform. Copy. Run uname -a. So it could be this or this, this or that. Copy. Will print all information about the machine in a specific order: kernel name, host name, the kernel release, kernel. The -a flag will omit -p processor type and -i hardware information if they are known. So to fall, I want to see how they're using it in context. To fall, include or mention, to leave out, fail or neglect to do something, fail or neglect to do something. The -a flag will leave out the -p, -i, copy. So we're gonna do the command uname -a, and it will give me something like this. Let's try it out. Linux, what we're running, the version, number one SMP, pre-MPT, dynamic Debian, 6.1, 6.11.5-1 Parrot, GNU Linux. Copy. Okay. For the above command, we can see that the kernel name is Linux, right? The host name is box. The kernel release is here. The kernel version is Ubuntu, SMP, Wednesday, date and time, UTC, year, and so on. Running any of these options on their own will give us the specific bit output we are interested in. Uname to obtain kernel release. Okay, so for example, like they said, running any of these on their own. Suppose we want to print out the kernel release to search for potential kernel exploits quickly. We can do uname-r to obtain this information. Let's do that. Uname-r. This is the release. Oh, so if this is a outdated release and they have vulnerabilities out, or if this version has, or this release has known vulnerabilities, it can be exploited. That's why they say search for potential kernel exploits quickly. We can use perfect. We did that. Generic. Yes, it gave us. With this info, we could go and search for this, and the first result immediately appears useful to us. Exploit database. Okay, where will we type it? Or where will we included. Oh, I guess this is it. Yeah, this is it. This would be it. EBDID, known common vulnerability exposure, author, local, exploit, if def, original discovery, exploit author. Okay, cool. It is highly recommended to study the commands and understand what they are for and what information they can provide. Though a bit tedious, we can learn much from studying the man pages for common commands. We may even find out things that we did not even know were possible with the given command. This information is not only used for working with Linux, however, it will also be used later to discover vulnerabilities and misconfigurations on the Linux system that may contribute to privilege escalations. Here are a few optional exercises that we can solve for practice purposes, which will help us become familiar with some of the commands. All right, we're moving along. About Linux exercises. The exercises provided for studying the Linux OS and its commands might not always be immediately clear in terms of what you need to do. And that's perfectly fine. It's even unavoidable. As you've learned from the learning process, super good module, yo. I mean, this module completely, I can say, literally changed the way that I think and learn. Learning something new can feel uncomfortable and may cause stress. They talk about stress and everything like that, and comfort zones and stuff like that. You can think of it like the first time you sat behind the wheel of a car and had to drive on your own. It was stressful because there were many things you had to focus on at once. But now with experience, driving is easier. Though you might not learn as much anymore, similarly in this module, you may find yourself in situations where you're unsure of what to do, but that's okay. You're in your cybersecurity journey, you'll often face such moments, and they're a positive indicator that you're learning something new. Overcoming these challenges helps you improve. Even if you haven't fully solved the exercise yet, that's the ultimate goal. Progress through learning. The exercises are intentionally designed to gradually push you out of your current knowledge and into unfamiliar territory. This progression is deliberate and ensures that you continue practicing, your experience and knowledge will naturally expand. While it may feel uncomfortable at times, this process is essential for growth. With each new challenge, you'll stretch beyond what you already know. And with constant effort, you'll find that your understanding and skills develop almost automatically. Keep practicing and you'll steadily grow more confident and capable in navigating the unknown. All right, this is what we've been running in the other window, as you can see. It is all here, but it's open in the other window, so it's open here. All right, cool. Let's see what we got. Answer the questions below to complete this section and earn cubes. Target, click here to start the pawn system. Cool. SSH to with user and password. Find out the machine hardware name and submit it as the answer. SSH to with user find what is this? Okay, so I got an SSH here. Okay. I already did that. Already. Targets are spawning. I think I already did that. Is that this? I don't know. I'm about to see. Give it a second. Find out the machine hardware name and submit it as the answer. Okay. Is it uname? Nope. Give me a hint. Take a look at the options for the uname utility. Okay. Okay, uname, and then option. Uname dash A. Okay. Machine hardware name. Okay, I think this is the hardware. The only reason why I think this is the hardware is because AMD I know is like a CPU, I think. Nope. Find out the machine hardware name. Machine hardware name. Linux. Patriot. Number one. Is this hardware? Is this hardware? Let's see. Nope. Take a look at the options for the uname utility. Okay, how do I find the options? Man uname? I think so. Man uname. Okay. Kernel name. No name. Kernel release. Kernel version. Machine. Print the machine hardware name. Okay. Nah, this is fun. I'm not gonna lie. Okay, so look, let's do that. Dash M, uname dash M. Q for quit. Uname dash M. And it just wasn't the end of it. So X8646 or 64. You see that a lot when you downloading things like 64-bit, I'm pretty sure. All right, so I'm pretty sure this. So you see, we had it here. We had it there. Ta-da! We working. Now we know how to print the machine hardware name. Uname dash M. Okay. What is the path to HTB's students' home directory? Great question. What is the path? What is the path? Let's see. What is the path? Well, this path. The path. What is the path? What is the path to the HTB's? No. What is the path to HTB student home directory? HTB student home directory. HTB. I'm not sure. We're gonna try though. Nope. What is the path to the student's home directory? Command not found. Try uname -- help for more information. Okay. How do I find the path? Let's see. How to find the path? So let's see if we can get some help from Google. Try. Okay, try HTB student as a directory name instead. Okay. So PWD. I remember that. Okay. Why do I remember that? Because from prompt description, I think it was. Nope. It was actually the same. Yeah, it was the same one. Crazy. PWD returns working directory name, so I can know what directory I'm in. Copy. PWD. That's the directory. Home Let's see if this gives it to me. Copy. Paste. Incorrect. Now let's try this. So switch this directory name. What? Still wrong? Oh, that's why. That's why it's still wrong. Pay attention. Okay. What is the path to the HTB student mail? Let's do LS. Documents, downloads, music, pictures, public, templates, videos. Interesting. How would I find that? Students mail? Can't find the answer. Can someone help, please? HGB student? So what is a VAR again? I don't see it here. I think I seen it in the last one, /var. Prompt description. No, where was it? Was it here? Nah, I remember seeing it. Was it get help? Nah. Was it introduction to shells? No. No. Looking for where I seen. Yeah, it was the first one. This directory contains variable data files. The var. Various data files. Like email, inboxes, log files, web application. Got you. Var. No. Let's see. No. No. All right. Let's try it. /var mail. Let's see. /var is a directory. So how do I get there? Think it's logical. Think about this. Where is the HTB student in mail? Oh, okay. So the user folder R usually under the sort of universal folder. Okay, let's try this. Let me see. It says incorrect though. Wrong one again. We got it. Okay. Which shell is specified for the HTTP student user? Which shell is specified? Oh, well. I think if I'm correct, it was. No. Okay. Close that for now. Which shell is specified? Let me see something. No. Which shell is specified for the HTTP student user? Which shell is specified? No? Okay. S. S. Nope. Okay. Unknown. Unknown. And the operating system. Oh. Is this it? No. Default login shell, I'm not sure. Yes, I use PS, which is introduced a bit earlier. However, now I use both. Shell and bash. So bash should be the correct answer. Yeah, it's bash there as well. Could you see in the quiz? Did the trick return? Right answer. So that's for the pass, specifically not the mail. Hey, you. Let's see. SSH username at IP. Continue with. Let me see if this works. Username would be this. HTTP. At IP address. IP. This. Let me see something because it did say something here. To HTB student, okay. Not found. SSH2 Academy with user. SSH2, maybe this. See what we get. Okay, I think we're getting somewhere. Did it copy? Copy. Nope. Okay, let's HTB_Academy. HT. I don't know why it's not typing. I'm not sure why it's not typing anymore. Nope. Not getting anymore. Do I close it down? I just want to find the show. I may have to reset it. Spoiler removed. Find out more about shell environment variable. Type your comment. Menu /bin/bash. That's what I. Let me see something. Wow. Okay, let me see something. I gotta get some batteries real quick. Give me 2 seconds. Okay. Still here, man. Still rocking. Still getting this knowledge, getting this information. Learning the fundamentals of Linux right now. Okay, let me run this command and see what I get. Oh, I did eliminate that. Shout out to the forum. screen it. Run my bash. Slash bin slash bash. I don't know if this works, but okay. Okay. Alright. Alright. Which kernel release is installed on, I think that was, yeah. No, yeah. AMD, yeah. Yeah, sir. I'm pretty confident. What? Which kernel release is installed on the format? Okay, I guess just that. No. 1 point, huh? Which kernel release is installed on this system? Okay, so kernel name, kernel release, print the kernel release, -R. Which kernel release is installed on the system? Yeah, I don't know how that's not the answer. How is that not the answer? Okay. Since that's not the answer. Is this it? I think so. I think so. Let's try this. No. Let's try this. No. No. Okay. Kernel release. I mean, which kernel release is installed on the system? All right. Right. That's what I did. Terminal output current, such as. Right, I did that. I'm going to do it again. 6.11. I'm not understanding what's that answer. Interesting. Interesting. No, I did that. It might be. I did that. That's what I did. All right, that's gonna stay there. Tried. None of them work. The host name, kernel version. Host name. I did that. I put this already. Okay. Yes. Not if it's showing to work. Yes. It's gonna be different from the HTTP student host and instance. Alright. They say hit this one above username password. Okay. I think I did that though. Reset targets. Isn't that what? Let me terminate this. Target spawning. Step 1. At the start of questions. Okay. Copy. Moving along, moving along. Alright, I think I'm gonna stop here. After I answer these questions. Stop here, take a little break.
Oh man, did I terminate it or did I I think I terminated it. Sheesh, I may not get my answer. Okay, I have to come back to that. It's cool. Mm, well, we'll come back to this tomorrow. If anything, I'll just get the membership on Friday. Let's see if we can get this one answered. Oh no, did I exit out? No. Oh yeah, I won't be able to. ENS192. But how did they get that answer? Uh, If config -A. Damn, I want that last one so bad. They use ChatGPT. I'm not mad at him, man. Hmm. Mm. Hmm. Let's see. I feel like I just typed this in. Wow.
Well, we did it. I feel way better. My OCD would have killed me, but how did they find this? Hmm. Damn, for about a week. Thanks, right? People are figuring out, people are getting the answer right, but they want to know they want to figure this out. I like this form right here. I'm going to save that. Yeah. Cool. All right. Now to end this video off, what I'm going to do is open up my virtual machine and I'm going to run Kali Linux. Give me a second here. Okay. Okay. Kali Linux. Give me a second here. Let me straighten this out. All right. So, terminal emulator. And home Kali text editor. All right, so let's run this. Mm-hmm. Mm-hmm. Okay. Sudo, I see it here. Okay. And let's see. Home Kali. Okay. And what's something else? Okay. What else? What other commands did we learn? Let me see something again. Sweet. Line 1, press H for help or Q to quit. Oh. And return for more, Q when done. Most options change. Okay. I'm seeing. What else? I got a cheat sheet. Got a cheat sheet here. Let's see if I can find it. What was it called? There we go. Okay. 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 Options where object address. Show routing devices. Okay. Network status. Okay. Sucks. I like that. I like tree. I like tree. Mm, uh, it was a command to use, but right now I'm using this cheat sheet. I'm gonna put it in the Discord. But yeah, let's see. Wonder where cat is. I forgot. All right, what was the command? What was the command for Linux? The command for Linux to Oh, my boy gave me some hotkeys. Shout out to Civil. Yes, sir. Yes, sir. Control L. Reset. That's what it was. Was it? Nah. Nah. Oh. What did I do? What did I do? Okay. What was that command? It's not Control L. It's not Control L because I just did that. Use clear dash X. Cat concatenate and print files. Okay. I wonder why that's doing that. Should I just exit out and then open it back up? Yeah. Okay. Main modes of operation. Finding manual pages. Okay. And okay. Copy. If config. 215. Alright, cool. So got the basics of Linux, man. Gonna keep on working on some of these commands. Okay, yeah, that does work. Control L is to clear it. I fuck with Linux though. It's cool. It's cool. Alright. That's the first module. First section. First two sections of this module. Give me a second. Is that it? I think so. Yes, it is. Number 3. Okay. Okay. Alright, so this we'll do tomorrow. I'll start doing this tomorrow. But we went through Linux structure, the distros, intro to shells, prompt descriptions, getting help, system information, and then we work on workflow tomorrow. I'm excited, man. Let's get it. All we do is numbers. Your boy Eddie One Take everywhere else, but on this channel right here, I'm RTX Eddie, man. We've been here for 3 hours learning about the fundamentals of Linux. Yeah, gotta love it. All right, I'm going back to hacking.